Good morning, everyone. Fluid mechanics. In this example, we want to calculate the resultant force on a gate shown below and also the location of the center of pressure Y sub Cp. So first part is calculation of the resultant force, and the formula for that, F sub R is equal to a specific weight of water times height of the centroid. If we start the height from the very top, that's our H direction. And then area is the area of the gate. So if this is our gate, which has like a 4 meter length and 5 meters width, as you can see here, the gate is 5 meters in width and like 4 meter in length. So F sub R is 9810, which is the gamma of water, times H sub C. If you dive deep to the centroid, this is 2 meter, and then like added like one more meter to that, that's H sub C. So how we can get that one? If this is 30°, the vertical component is half of that, and that's 2 meters, and half of that is 1 meter, which is added to these 2 meters. So it just make it like 8c, bring is that's yc centroid, and it just make it like 8 sub c is equal to 3 meters. That's how we get this number. Then area is definitely area of the gate, which is 4 meters times 5 meters, and it just gives us a resultant force of 588.6 kilonewtons. And then in the second part, we are going to calculate the location of center of pressure that we definitely know it's a little below center of gravity. So in the second part, if we just define the y-axis like what you can see here, again, if this is our center of a centroid y sub c, then the formula for ycp, or y component of center of pressure, that's yc plus ixc, moment of inertia for centroid over y component of centroid times the area of our gate. So if this is 2 meters, this height is 2 meters, and this is like 30 degrees due to this one, then it just gives us the hypotenuse itself is like 4 meters. Then as you climb down in y direction, the total length is 4, so half of that is 2 meters. So our yc based off our y-axis, it just gives us a numeric value of 6, then plus a 112 4 cubed, this is ixc, 112 4 cubed times the width, which is 5 meter, over yc, which is 6 times 4 times 5, which is the area. And if you add them up together, it just gives us the y component of cp stands at a 6.22 meters from our axis. So yc is 6 meter, then ycp is just 0.22 meters or 22 centimeters below the center of gravity. As you can see here, all the time ycp is standing below the centroid, and as you dive deeper into the deeper water, the distance between yc and ycp getting closer and closer and closer. Thank you. We'll solve more problem in forces on gate in fluid mechanics.